Okay, so for this lesson, we are going to work with exponents and how to combine things. We're going to have a little bit of vocabulary words and then some practice with those vocabulary words. So what I'm going to start off here for you is just an example of something similar to what we're going to work with. Got a lot going on my screen. I don't know what's wrong with me, guys. Okay, almost got it. Here we go. So if we have something like this, 3x to the 5th power, let's talk just briefly about vocabulary. Okay, so things to know is that this 3, I recommend you write this down, is going to be called the coefficient. Okay, that is a number out in front of any variables that we have. Okay, this is a variable. Okay, and this is our exponent. If we had another, like a number, so let's say we had 2 to the 7th power, another vocabulary we could use. So this is our exponent, just like we had before. And either with this x or this 2, doesn't matter which, we would still call this the base. Okay, so I'm going to say that this is the base because it is the base of something with an exponent. I think that covers most of the vocabulary in this section, but I wanted you guys to kind of have that in your head so that, you know, we're all talking about the same language. So I'm going to go ahead and erase these, and we're going to talk about our first exponent rule that we're going to be using. Okay, so this is a rule called the product of powers. I'm going to write that here, product of powers. Product, remember, means that we're multiplying something. Okay, so an example of this would be, we have negative 3x squared. We consider this a monomial. Okay, that's another good vocabulary, a monomial. Okay, and that's because it's one term. It has a coefficient, it has a variable, it has an exponent, and it's all kind of grabbed together. Okay, so that's a monomial. I probably should have hit the erase button there. Whoops, okay. And then times another monomial. We're going to do 3x to the 5th. Okay, now what we have here is a multiplication problem. We are going to multiply the coefficients. So that's the negative 3 times 3 is negative 9. Then we're going to deal with these exponents. Okay, and we have a rule for that, but let me show you what we're really looking at here is x times x, that's the x squared, times x to the 5th, that's x, 2, 3, 4, 5. Okay, so we truly have negative 9x to the 1, 2, 3, 4, 5, 6, 7, x to the 7th power. Okay, and you'll notice that that's 2 plus 5 is 7. And so that's our rule for this, and we can use that rule and write it like this. I don't know why I put parentheses out front. We did not need those anymore. Okay, so negative 9 x to the 2 plus 5, which equals negative 9 x to the 7th. So that's the rule, the product of powers. We're going to have several rules. And one way that you can write these rules easily is you're going to want the example of how to do it. But then we have kind of a general way that we can write this as well. We can say x, whoops, to the a, I don't know why it's doing that, times x to the b equals x to the a plus b. Okay, so this is how we write our general rule. And so I would kind of make a spot in your notes to write the general rule plus the example of how to use it. Okay, so that's real quick, the example of product of powers. I'm going to go ahead and do a couple more examples real quick for you so that you just have a few more in your head that you know exists that you can come back to. So let me do another one. This is 10 to the m to the 5th and 5m to the 3rd. Okay, so we're going to start by multiplying those coefficients again. So 50. And then we're going to follow our rule this time. Instead of writing all those m's out like we did, we're going to follow our rule. So m to the 5 plus 3. So that is 50 times m to the 8th. Okay, let me know if you have any questions about this. Happy to help you on those. Let me figure out how to stop the video.